Okay, this video is just me recording my process on creating the button panel challenge that Craftsy gave. So basically there are 6 buttons like these, and then each of the buttons have to power its own individual redstone lamp shown like that. More specifically, each of the side buttons have to power the lamps here respectively. And then the top and bottom will be connected to this and this. So yeah, there's no restriction on the ground, otherwise it would not be possible basically, unless you do some wireless techniques or whatever. But yeah, either way. So yeah, just this video is just going to be me going through how a restoner thinks and tackles this problem. So yeah, let's do it. Now, the main problem is the top button. So we basically need to use quasi-connectivity to solve things. So, we will have this, for example. But then, of course, we will also know that all of the other buttons would quasi-power this piston. So it would just be that later we will have a circuit that filters stuff, basically. So yeah. Now just to yeah, this button also would affect basically every single piston. If I use pistons, I can use droppers, for example. So yeah. Yes. Now, you also would see that, for example, I power this button, nothing happens. And that also means that we need to have a clock. So an example would be this. I'm not sure that if this is going to be used. But yeah, this works. And also, if you push it one down, it also works. That. Just check a bit. Yeah. And it seems that the floor itself can also have wiring, because just use carpet to cover up some blocks. So I suspect that there is going to be some wiring. So we can relax our assumption that we can just place some surface here. Of course, I will try to make this floor as seamless as possible, and only having these four to be pistons. But in case if that doesn't work, that oh well, doesn't really matter. And also, let me just see if this works or not. I think it will. So, yep. I'm not sure how that helped, but hopefully it did. Because now I can replace this with a dropper as an example and do this. Of course, there will still be, for example, landlocked issues because, let's suppose that we replace all of these with droppers. Then if we don't want to use the floor, then this also means that, this observer is landlocked. And I want to comparison actually. I'm not sure if this is reliable. Yeah, it's not reliable. Unfortunately. So what I'm planning now is to, think of a way to isolate this observer signal. So just find a way to take an output at least. It might be good that we don't use a clock like this. Instead, we just use let's see. So, for example, we can use this. And then, of course, we don't really prefer, having a constant clock like this to power piston, something like this. So, something like this might be good. Yeah, there we go. So we do find a way on how to solve the land issue, and this also automatically pushes up. Although I'm quite sure that this is not reliable, actually. Because to my knowledge, there can be situations where this can the clock will stop when you push it down. So my remedy for this is to use a sticky piston. Now you might also see that I'm not exactly sure on which cases are unreliable and which cases are reliable, but then sometimes it's like that. So we just do some proving on these scenarios. So yeah, I mean a sticky piston works basically, Although in this texture pack, you see it has this texture difference than the normal piston back or the dropper back. But then in normal textures, you won't see this difference. So it's all good actually. Did I? Oh, apparently retracting it will actually fail. Hmm. Let me try one block downwards. And make this glass for now. Yep, then that works. So that's nice. Okay, so we basically solved the issue on the top button. So at least we get an output for now. And of course, the other buttons would all work already. Because this clock is going to update this piston. And they would also, this piston moves will also update any droppers being quasi-powered. So there you go. Also, let me just check a bit on how long the lamp's power. I don't think it actually, yeah, it can just be one tick, so a bit lame, but it's still it is better because now we don't have to worry too much on how to power the lamps. All we need to do is just to power it, pulse it, I would say. So yeah. So of course we don't want to power it like this because that'll create a clock which is not nice. Although of course there can be methods to avoid clocking even if you directly power it, but then it's just nice to not have this fuss. And then now here comes the fun part, which is to do the logic. Yes, the logic part is probably one of the most annoying ones. Especially we have the scenario where we need to differentiate between the top button and the bottom button. The sides are still relatively okay-ish. And then we also need the top and bottom button to basically stop any powerings. Now the top button doesn't even power any of the droppers, so that's nice. But then the bottom button, we basically need to prevent any sides to power. Now, if these lamps aren't here, what I plan to do is to do something like this. Unfortunately, these lamps are here, so whoops. And also, this is the most troublesome one. Let's just say. And also, of course, a nice scenario is to do something like this. So we want to use a piston like this because we want to retract it without getting detected by the observer. But then the problem is that all these others have a piston like this. So if you place a sticky piston like this, you basically already limited the possibility of doing this. So that's no good. Oh, actually, just to mention, there's actually a very nice solution to this. That's because the only scenario where we need to stop the sides from powering is actually the bottom piston. And then while the sides are unaffected. So what we can do is a very symmetrical solution, which is this. So that solves all our problems already. And also, because it only needs one pulse, so I guess I would want to use a sticky piston now that I can just simply remove the block instead. So yep, so that's nice. Then to connect these are going to be very simple. I tend to use hoppers rather than no blocks, rails, droppers. So yeah, bear with me. So now in case this powers, we have this. And then the top powers, nothing really happens. Then this powers. So yeah. So that's nice. Very nice indeed, actually. So yeah, that solves our bottom button issue. And then now all we need to do is to differentiate between the top and the bottom button. And also the size, I guess. Now notice because we have these pistons already, then we must have this observer, I guess. It might not be that necessary. Let me think. So the scenario I'm thinking is, what if I do this? So would it mess up anything? It would for the top button case. So let's not do that. Now, the reason why the top button case would mess up. So imagine that, you have this piston spitting out the block, and then later, let's say the top button would go back, and then this is at here. And then later, oh, actually, it looks fine because when the top button releases, then this is going to spit out again, and then yeah, this is actually a bit slower, and then this here comes by and then just retracts it back, then it actually looks fine. So thankfully, we can actually do this. As long as these observers have delay compared to these, which they surely have, basically. So no worries here. So let's suppose that we want this to be the bottom button and this to be the top button. You might think what I'm doing. I want to place dust like this. Yep, and then the reason why I wanted to do that is like so. Now let's just forget how we are going to power this first, because it can be quite troublesome. But yeah, you get the idea that what I'm trying to do is that, so any of the side buttons or the bottom button powers, then all of these is going to retract, so the top one would not be controlled. So I guess here we don't want to exactly do that. But yeah, at least for a top button in case we do want to do that. So the bottom button, we want an AND gate case. So we can try to do something like this. I'm not sure if it works or not. If it doesn't, then we can just use something new. We want a bottom button. Okay, it doesn't work. That's fine. We just have to do some alternatives. And then while the top button, it does nothing. This button also does nothing by itself. This button also does nothing by itself. So yeah, that's very nice. And then now we can just connect it to here. And even better, we don't have to do the solid block. Just have to do this. Yep. Okay, so now let's solve the top button case. Although we have a great idea on how to do stuff, which still not that good. So let's just try to avoid powering this because I wanted to. Now notice that this is also not a good solution. The reason is because we really need to take an output from here, which for example can be a cauldron. it can be like that, but then, it can also be just a simple observer. It probably, never mind, it won't be an observer. The reason why it won't be an observer, it would power any of the 4 blocks like this if it faces the side. Facing the top is meaningless. Facing the bottom clocks this, so it's no good. Now, it's quite obvious that we're going to do it from here, I guess. Now, of course, we can still do this kind of dust like this. We just need some special arrangements here, which fortunately we do have. Let me explain a bit later, but basically just use a qua, something that can be QC'd, and then have an updater here. Or even better, do this. So any side button would push that block out. What happens to here? Oh yeah, right. That's not good. So that's my mistake. This is not a good solution. So let's try a new solution while we can. So yeah, sometimes mistakes will happen, so not that fortunate this time. Yeah, that's also a problem with button input, I guess. Well, we don't have a choice, so. I mean, button input gives us some good things like this, but then here it's just not quite good. We'll just remove this now. I mean, I have a very wacky solution. I'll have to test it though. Okay, problem solved. That's fine. So what happens is that this is a very well-known circuit that to here, it only emits one pulse each time instead of 3 pulses. That's because the observer is going to detect the piston head, but then it will retract before it can even give a pulse. And when it goes back to this position, it cannot give a pulse. So it basically affects here. There's no block updates from here, so this is going to be just one pulse now. Problem solved, so yep. Thank God. So all the stuff we have before, we can use that now. So let's check bottom. Yep. We are just going to add an observer here just to update the comparator. There we go. And of course, some wacky problems like, in case if we want to do this, then we have this that affects stuff. But luckily, the thing is that just do it on the other side. That's it. So let's remove all these, as we are going to do it literally just on the other side and everything is fine. Oh, although here is not fine. I guess we do have a problem. Whoops. Anyway. So, because we are definitely going to have this in some case. So let's find a better solution now. I want it to be also a bit faster. So I'll do this. Perhaps so let's just check. Whoa, that's not good. Because we haven't even wired that thing. Whoops. Oh, wait, we did, but then just it doesn't work. Hmm. That's not good. Yep, that's quite bad actually. I mean, we don't have to necessarily try to use that method. We can just use another way to cut off the signal. It will just be a slightly more annoying. Actually, I have the perfect idea. Hopefully, it's a perfect idea. I'm not sure either. Doesn't seem like it. But it's still a good start because this, and now we can just think of how to control this thing here. Do you have anything that obstructs it? No. Check. Uh-oh. Doesn't look good. Let's fix that. Actually, that doesn't fix anything. I'm not sure if this is fast enough, hopefully. Sometimes, of course, you can try to count the timings, but then sometimes it's just faster to just test it. So that's why this time I'm not going to do that. It's not fast enough. Like so. Looks okay. Oh, that's because I haven't connected it to anything. Of course. I guess we just need a better technique because this is just not a good way. To do stuff. We have multiple ways doing so. Whoops. Now this time I'm going to use rails just for speed purposes. There we go. Neat. Of course, the observer is going to face the wrong way. What happened to here? What? Anyway. Oh, that doesn't sound good. Ah, of course. So, to tackle this stupid stuff, there we go. Just trying different combinations and see if it will still break anything. If not, I think that is it. So hopefully you now understand a bit more on how we try to do stuff in Redstone. And use some carpets to, make this look nice. And yeah. So yeah, thank you for watching. I'll see you in the next video. This took 1 hour.